Hello, I'm Dr. Mohammed Ikram. In this video, I introduce our paper, a novel sequential block path planning method for 3D unmanned aerial vehicle routing in sustainable supply chains, co-authored with Professor Robert Sroufe. Unmanned aerial vehicles can make logistics faster, more flexible, and more sustainable. However, routing UAVs through dynamic three-dimensional environments is difficult. Buildings, moving obstacles, changing delivery priorities, and unexpected disruptions can force a UAV to recalculate its path in real time. Traditional approaches are often designed for two-dimensional or static environments and may require substantial computation. To address this problem, we developed the Sequential Block Path Planning method, or SBPP. Our method combines three elements: queuing theory for assigning tasks to UAVs, a modified D Lite algorithm for dynamic navigation, and a sequential block structure for simplifying complex three-dimensional space. The process begins by dividing the environment into large cubic blocks. A preliminary route is calculated at a course level. The method then progressively refines the route through more detailed levels until an efficient flight path is produced. When a new obstacle appears, SBPP updates only the affected blocks rather than recalculating the entire route. This enables faster and more responsive path planning. We tested the method in a 64 by 64 by 64 simulation environment with 12% obstacle volume. The experiments included both a single UAV and a network of 4 UAVs assigned to 4 destinations. In every test case, SBPP achieved the lowest pathfinding time compared with A* and D Lite. For example, in one route, SBPP required only 18.06 meter-seconds compared with 24.37 meter-seconds for A* and 22.84 meter-seconds for D Lite. These results show that SBPP can generate shorter, collision-free routes while reducing computation time. For sustainable supply chains, this can mean lower energy use, fewer delays, improved fleet utilization, and more reliable deliveries in complex environments. Our study provides a practical framework for faster, safer, and more sustainable UAV logistics. Scan the QR code to read the full paper. Thank you.